Today we are going to go over 8.5 part 2, converges absolutely or converges conditionally. This is also about alternating series. The definition right here, given a series A of n is any alternating series. So negative 1 to the nth power is also included in our A of n. So if the absolute value, if we put the absolute value there, if the absolute value converges, then we call the series converges absolutely. If the absolute value diverges, but the original series converges, then we call the series converges conditionally. So we just need to remember, if the absolute value converges absolutely. So let me show you some examples. So given example 1, how do we check if it converges conditional or absolutely? So first of all, this is the alternating series. We have negative 1 to the nth power here. So first, we put the absolute value there. So when we add absolute value there, this series will become n over 2n squared minus 1. This is just a regular series because the absolute value, negative 1 to the n, is gone. How do we check the convergence of this series? Nth term test is not going to work, it's not geometric or p-series. We can use the limit comparison test. So the limit comparison, we can compare with n over n squared, which is 1 over n. So we can do the limit and go to infinity. N divided by 2n squared minus 1 over 1 over n, which is n squared over 2n squared minus 1 as n go to infinity, which is 1/2. That means the two series has the same property. So based on limit comparison test, the series, because 1 over n diverges, so the series also diverges. So the absolute value diverges. Now we need to check the original series given sigma n equals 1 to infinity. The original series, which is an alternating series. So A of n here, which is n over 2n squared minus 1. Three conditions, A of n positive, as n go to infinity, A of n, which is 0. Next, we have to check if this function is decreasing. Because there's no power or exponential function here, we can use subtraction. So an plus 1 minus an. N plus 1 over minus n over 2n squared minus 1. You can check the algebra from my answer key, and at the end, I have 2n squared minus negative 2n minus 1 times which is negative over positive, which is negative. So that means it is decreasing. The algebra here is very tedious. So we can use another way to prove it's decreasing. We can use the derivative. We treat an as a function of n. We can take the derivative, use the quotient rule, minus n times 4n, which gives us negative 2n squared minus 1 over 2n squared minus 1 squared. And we can tell it easily is decreasing. So an prime is, the derivative is less than 0, so A of n is also decreasing. This way is much easier. So because all the three conditions are satisfied, so the series, alternating series, converges. Because absolute value diverges and original series converges, so our final conclusion, the series converges conditionally. Given example here, first we put the absolute value there, will be equal to n goes to 1 to infinity, n over 2n minus 1. So this series, as we know, based on the nth term test, it diverges. Now we need to check the original series. Three conditions, a of n, so a of n equals n over 2n minus 1, positive, limit as n go to infinity, which is 1/2, not 0, so this also diverges. Because both of them diverges, so original series just diverges. Let's look at the next example. We put the absolute value there. So this is the p series, 3 over 2. P equals 3 over 2 greater than 1. So this series will converge. So absolute value converges. So our final conclusion, the series converges absolutely.